Hey everybody, today we're going to be doing the derivatives of all of the major trig functions. Actually, we're gonna skip to the derivative of sine is cosine, cosine is negative sine. We're gonna basically assume that those are true. And the way you would derive those, I think there are a few different ways, but one major way is just by looking at the graph of sine, just being like, oh yeah, the slope at each point, plotting that and be like, oh yeah, that's basically the derivative of cosine. And doing the same thing with cosine and negative sine. So we're going to assume that those are true, and we're going to use those to find the derivatives of all of the other four other major trig functions that we're going to encounter. So the first one I'm going to say is tangent. So the derivative of tangent of x, right? So tangent is just going to be sine over cosine, right? So this is still the derivative, but of sine of x over cosine of x. And we can use the quotient rule. Isn't that exciting? Don't we love using the quotient rule? It's, obviously, like, we can't always use whatever rule we want, but yeah, so I'm going to do it down here. So sine over cosine, so let's start with low d high. So we have low times the derivative of sine, which is cosine. So, and I'm just going to forget the parentheses. So cosine times cosine minus sine, so high times d low, I'm sorry, so it's low d high, yeah, so minus high d low, derivative of cosine, I said, is negative sine, so then I'm going to say times a negative sine over low squared, which is just cosine squared x. Right? So negative times negative, that just gives us a positive, so I'm just going to say it's a positive. I'll just get rid of this guy, right? So cosine squared, right, that's what cosine times cosine is, plus sine squared. This is actually equal to 1 as a Pythagorean identity, and I could make a short out of this because it's really not too hard to go through. But yeah, so that is the Pythagorean identity. Basically, if you just look at a right triangle, you'll be able to derive that. So 1 over cosine squared, right, because we have 1 on the top, and then over cosine squared, this is just equal to secant squared of x. So this is the derivative of tangent, right? And actually, I wanted to write, the reason why I had that red marker there is because I wanted to write my answer like this, just so we have them all in red. So yeah, this is the derivative of secant squared, the derivative of tangent, which is secant squared of x. So now the second one is the derivative of cotangent. So cotangent of x. So this is cotangent. So this is, again, same type of thing. We're going to just do cosine over sine instead. And again, we're going to be using the quotient rule. So low times d high, which is just going to be a negative sign, so times negative sine, minus high, which is cosine, so low d high, yeah, minus high d low, derivative of the low is sine, which is just cosine, over low squared, which is sine squared of x, right? So what we have here is a negative and a negative. We can really just factor out this negative, right? So I'll just factor it out, and then it's going to get rid of here. This is just going to turn to a positive. Yeah, so this is what we have, right? So negative, we factored the negative out, and then we have positive in here. And this, again, is just 1, right? So this is equal to negative 1 over sine squared of x, right? We have that negative that we factored out. And this is precisely equal to negative, I don't know why there's a black line through there, but it's equal to negative cosecant squared of x. So that is what that is equal to. And I realize the inconsistency, so if anybody's OCD out there, I got you, don't worry. We got that black equal sign there, all right? So these are 2 of them already. So the last 2 are actually super easy. We're not going to use the quotient rule anymore. Goodbye quotient rule. I mean, we could. I'll show you why, but yeah, so we're going to take the derivative. Let's just do of secant because it really doesn't matter, right? So this, remember, is the derivative. So secant is just 1 over cosine, so 1 over cosine of x. So yeah, here we have an option. We could do quotient rule. But why would you do quotient rule whenever you have a 1 on the top? Like come on. Like, and that, like, I don't know why you would want to, but really we can just say this is cosine of x to the -1 power, and then use the chain rule. Super easy, right? So when we apply the chain rule, we're just going to have a negative out front, negative cosine of x to the -2 times the derivative of the inside, which is just negative sine of x. So what we have here is this negative and that negative cancel, so we're done with negatives. We have the sine x on the top, and then a cosine squared on the bottom, because this was to the -2. We're moving it to the bottom, still 2 of them, but it's on the bottom. So yeah. So then this, we can think of as sine over cosine times that one other copy of cosine, right? So we're splitting this up into basically 2 fractions, multiplying them together. And so this is equal to, and actually I should have done it as 1 over cosine times sine over cosine, because this 1 over cosine is secant, alright? And then the sine over cosine is tangent. And this is our answer. And yeah, we could have done tangent times secant, but it's typically secant times tangent. That's how you normally see it. I don't know why. And again, let me just change this back to a black plus sign. Let me not make it look like that. It is like that. And sorry, I kind of cut it off a little bit there, but it's okay. So the last one we have is the derivative of cosecant of x. So again, same process. So we're going to say it's the derivative of 1 over sine of x, right? And this, again, it's just, we can say it's the derivative of sine x to the -1 power. Same type of thing here. So we're going to keep going. Chain rule again. So we got negative times the sine x to the -2 times the derivative of the inside, which is just sine. Derivative of sine, we said, is cosine. So we have that cosine. So now we only have one negative here, so we're going to put that negative. And then actually, let me be consistent and put this on the second line, right? So we have the negative. It looks like an equal sign. We have the negative. We have that cosine on the top over the sine squared on the bottom. All right. So this, we can say it's negative. Yeah. So I'm going to say it's actually -1 over sine x times cosine over sine x, right? So we're basically splitting up this fraction, multiplying these two together. These two are equivalent. I'm sure you can see that. And basically, okay, let me put that equal sign there. And basically, we can just end up with, all right, well, negative, we have the negative 1 over sine is cosecant, right? So cosecant times cos over sine is cotangent. And this is our final answer. So these are the 6 major trig functions. 2 of them we already assumed. Easily derive these with the quotient rule, easily derive these with the chain rule, or the quotient rule, but chain rule is better. So yeah, this is just an easy way. In the future, I'm going to do the derivations of the inverse trig derivatives. So yeah, that'll take a lot longer. But I hope you guys enjoyed. Thanks for watching, and I'll see you in that video. Bye, guys.